There are four ingredients to ozone depletion in the Arctic. The first thing you need is you need high levels of chlorine and bromine, which come from man-made chemicals, chlorofluorocarbons and halons. The second ingredient is you need very cold temperatures to form polar stratospheric clouds. The third ingredient you need is you need a vortex, a current of air that surrounds the Arctic to confine air in the stratosphere over the Arctic, in fact being a containment vessel. And then the fourth ingredient you need is a little bit of sunlight. So you take all the high chlorine and bromine levels, a little bit of sunlight drives what's called a catalytic reaction that attacks ozone and eats ozone. So you can destroy ozone very, very quickly if you form these polar stratospheric clouds in the cold temperatures. That activates chlorine, the chlorine attacks ozone, and ozone goes down quite rapidly. Over the last few years, occasionally we see very warm conditions and occasionally we see very cold conditions over the Arctic. Ozone is the Earth's natural sunscreen. Solar UV radiation. UV radiation can break the bonds of molecules, and particularly in your skin, DNA molecules. UV radiation can break down DNA. And so excessive UV, we have repair mechanisms in our skin that can repair our DNA, but excessive UV can lead to things like skin cancer, cataracts in your eyes. It can suppress your immune system. So there are a number of health effects from excessive UV radiation. Because ozone screens UV radiation, that's a very good thing. So ozone depletion is you reduce the amount of ozone, you increase the amount of UV at the surface, which leads to more skin cancer, more cataracts, more sunburns, for example. The most vulnerable people to UV are people who go outside and spend hours in the sun. Okay? It's a good health practice to limit the amount of time that you spend in the sun. Don't go out and bake yourself out in the sun. That's not a good health practice.